Hello, it's Mr. Pierce. Today we are going to be working on subtracting mixed numbers with renaming. If you'll notice, these two problems that are written here say the exact same thing. They both say 3 5/10 minus 1 6/10. Let's start out first of all with the one that is a decimal. If I start in the tenths place, I cannot say 5/10 minus 6/10. So as we know, we must borrow or regroup. So if I go over to the whole number place, I am able to borrow, one whole. So if I take one whole away from that, that means I can bring back one whole or 10/10 to the tenths place. So if I took away one whole, that is 10/10, but I already have 5/10, so that makes this 15/10. Now I can subtract. 15/10 minus 6/10 is, of course, 9/10. Our decimal, of course, goes straight down. 2 minus 1 is 1. So our answer is 1 9/10. To the right, we see the exact same problem. And we have to do the same steps. When I go to subtract the fractions, I cannot say 5/10 minus 6/10. So once again, I have to go over to the whole number place and borrow or regroup. If I take 1 away or borrow 1 from the 3, it becomes 2. I took away one whole. Now that one whole is 10/10, but I already have 5/10. That makes this become 2 15/10. If we look back over here, we will notice in the decimal that it also says 2 15/10. Now I can simply bring over the 1 6/10 and subtract. 15/10 minus 6/10 is 9/10. 2 minus 1 is 1. You will notice that these two answers say the exact same thing. 1 9/10. Here we have another example. If I start in the tenths place, I cannot say 7/10 minus 9/10. So once again, I have to borrow or regroup. So if I go over to the whole number place, I can regroup. This becomes 7 ones. I took away one whole. Well, one whole is equal to 10/10. I already have 7/10, so that makes this 17. So you will notice that I now have written 7 17/10. 17/10 minus 9/10 is 8/10. Of course, the decimal goes straight down. 7 minus 2 is 5. So our answer is 5 8/10. In the one that is a mixed number, of course the denominators are already the same. That's important to realize. I cannot say 7/10 minus 9/10. So again, I go over and borrow or regroup. That makes this a 7. So that becomes 7 ones. Now I took away one whole. In this case, that is the same as 10/10, but I already have 7. So that becomes 7 17/10. Just like it did as a decimal. Now I can bring over the 2 9/10, and once again I would subtract. 17/10 minus 9/10 is 8/10. 7 minus 2 is 5. So we will notice that that says 5 8/10. In the fraction world, we know to simplify that to 5 4/5. These are examples of equivalent problems. 5 8/10 as a decimal is the same as 5 8/10 or 5 4/5. In this next example, we have 5 1/8 minus 1 3/8. Now clearly, I've always said that we should look at the fraction part first. Can we say 1/8 minus 3/8? And of course the answer is no. Although the denominators are the same, we cannot simply subtract here. So I have to do borrowing or regrouping. In order to do that, I simply go over to the 5 and I borrow or regroup. So if I take 1 away from the 5, it becomes a 4. Now I took away 1 whole. 1 whole is the same as 8 eighths. So if I think about that, and I have the 5 became a 4, and I had 8 eighths, but I already have 1/8, this becomes 4 and 9 eighths. Now I can simply bring over the 1 and 3/8, and I can simplify. Okay, I can see that already. So 9/8 minus 3/8 is going to be 6/8. Okay, 4 minus 1 is 3. So I said I could simplify, so I can do that by dividing both the 6 and the 8 by 2. So my final answer here will be 3 and 3/4. In this next example, we have 6 and 1/9 minus 3 and 2/9. So I start with the fractions. Are the denominators the same? Yes, they are. So now I should be able to subtract. But when I go to say 1/9 minus 2/9, I realize I cannot say 1 minus 2. So once again, I must borrow or regroup. If I borrow 1 from the 6, it becomes a 5. Now, I took away 1 whole from that 6. So in this case, that means that that 1 whole would be the same as 9/9, because 5 and 9/9 would be 6. So if I took away 1 whole, which would be 9/9, and I already have 1/9, that will make this 5 and 10/9. Now I can simply bring over the 3 and 2/9, and I should be able to subtract. 10/9 minus 2/9 is 8/9. In the whole number, 5 minus 3 is, of course, 2. So our answer is 2 and 8/9. And this will not simplify any further. In the next example, we have 7 and 1/2 minus 1 and 2/3. One thing we will notice right away is the denominators are not the same. So the first thing we have to do is make these have the same number of pieces. Once again, this goes back to what we've been doing. Okay, so we would say, okay, if one denominator is 2 and one is a 3, we can multiply 2 times 3 and turn them both to sixth fractions. So that's the first step we need to do here. So we turn them both to sixth. So on the bottom, what times 3 gives us 6? That would be 2. So if I multiply by 2 in my denominator, I must do the same to the numerator. 2 times 2 is 4. So 1 and 2/3 is the same as 1 and 4/6. On the top, what times 2 gives me 6? That would be 3. Okay, so if I multiply by 3 in my denominator, I have to do the same to the numerator. 1 times 3 is 3. So now we have 7 and 3/6. Here's where our problem now lies. We cannot say, and again, we need to make sure that we try to subtract the fraction first. I cannot say 3/6 minus 4/6. So I'm going to have to borrow or regroup. So I go over to the 7. And if I borrow 1 from the 7, it becomes a 6. I took away 1 whole. Now we will notice that the denominator was a 6. So 6 and 6/6 was the same as 7. So let's go back to that for a second. If I take away 1 whole from the 7, it becomes a 6. That 1 whole is equal to 6/6, but I already have 3/6. So that means I rename this as 6 and 9/6. Now I can bring over my 1 and 4/6, and I can subtract. Okay, 9/6 minus 4/6 is 5/6. And 6 minus 1 is 5. So our final answer to this problem was 5 and 5/6. In this last example, we have 3 2/3 minus 1 4/5. The first thing we should notice is that the denominators are not the same. So we need to make them have the same number of pieces. In order to do that, I can simply multiply the two denominators. 3 times 5 is 15. So I'm going to make each of these have 15ths for a denominator. And then we're going to find equivalent fractions. So let's start with the bottom fraction. What times 5 gives us 15? That would be 3. So if I multiply by 3 in my denominator, I must do the same to the numerator. 3 times 4 is 12. So 1 4/5 is equivalent to 1 12/15. In the top one, 3 times 5 is 15. So if I multiply by 5 in my denominator, I do the same to the numerator. 5 times 2 is 10. So 3 2/3 is the same as 3 10/15. So, as I've said in the past, we always try to subtract the fraction part first. I cannot say 10/15 minus 12/15. So I have to borrow or regroup. So in order to do that, I have to go over to the 3, and I'm going to borrow 1 whole from that, which would make it a 2. Now I took away 1 whole. That 1 whole in this situation is equal to 15/15. So 3 wholes would be the same as 2 15/15. So if I go back to it, I took away 1 whole, which made it a 2. That 1 whole was equal to 15/15, but I already have 10/15, which makes this become 2 25/15. Now I bring over the 1 12/15, and I can simply subtract. 25 minus 12 is 13. So that would be 13/15. 2 minus 1 is 1. I know that 13/15 will not subtract, so my final answer is 1 3/15. I'm hoping that you're finding subtracting mixed numbers with renaming to be an easy process. If not, we will continue to work on it. It is probably one of the more difficult things we do with fractions. Good luck. Have fun.